trailblazers of the program. I want to talk for just a few minutes to introduce the program, talk a little about the evolution of it, where it came from, and where I think we're going with it, and then turn it over to the team to talk about their particularly cool, crazy invention. Well, CCEW is not your grandfather's CCEW. If you were at our final presentation, you heard the whole spiel. We've got 65 interns across 3 campuses, tackling all kinds of big challenges in technology and social enterprise, in product design and software. We've touched all kinds of different interesting problems, both here in the U.S. and globally. We have evolved to a number of very interesting service lines, from technology transfer, which was their core bread and butter when the program started, to the software business accelerator, which in many ways is like the Agile Product Design program, but for software. We have programs with national labs, including the Lawrence Livermore program during the summer that a handful of you here in the room have been a part of and are going to be a part of. We have our partnership with Ames National Lab and the Rare Earth and Critical Materials Institute program there. We have our Oklahoma Funding Accelerator, a consulting group for startups and local lifestyle businesses and entrepreneurs. We have grown tremendously from our initial roots, and we've continued to apply the same methodology, involving rooted in methods from management consulting from around the world. We've brought some of the best thinking around lean startup methodology and infused it into the program. We've got really a great methodology that we continue to build out new service lines and new expertise, from software to product design to technology transfer. And so the Agile Product Design program stemmed from a little bit about this desire to grow into new service lines and new expertise. And we realized that there really is a need and a niche for this idea of product design here on campus, and we wanted to take the lead. I think also a number of us on the staff just had this sort of this gut interest. We just are really intrigued by this idea of product design, of user-based design, and wanted to explore that using the program and sort of scratch that itch that we had. APD fits perfectly into the program, and it is one of many pillars of excellence and of knowledge and leadership that we have, not only here on campus, but much more broadly. And even though this is our first attempt at it, I foresee many more teams, much greater expansion of the thinking, the methodology, and the approach all over campus. I think we need it. I don't have the statistics to give to you, but I can give you sort of my gut feel. As over the past couple of months, we've interviewed about 25 people in and around campus about what's going on in innovation and interest in sort of bringing together in an interdisciplinary way the tools of a makerspace, of visualization, of collaboration. And I know there are bits and pieces of it out there, but there's something missing. And when I then compare what we have, we've got great stuff. We've got the engineering practice facility, which is great and serves sort of the teams that are competing. We have certainly great expertise in our visual communications group. I think we have lots of very interesting study going on in our entrepreneurship program around product design. So I think we've got the bits and pieces, but when I look at what we have and I compare ourselves to places like Carnegie Mellon, that's the host of the Disney Research Lab, and now, as we were just talking, a wellness center that brings together all the bits and pieces of interdisciplinary design focused on the human condition. When I look at the Stanford D School and the kind of collaborative space that they have continued to grow over time there on the Stanford campus. When I look at MIT, which has invested heavily in MIT Nano, the small bits and pieces study area, the MIT Media Lab, and you put all those together and see the incredible amount of investment put around this idea of innovation and design, my reaction is we are way behind. We are just way behind. And so for me, this program is the very first, very small step getting our general campus much more focused around this idea of interdisciplinary innovation, bringing together the best of various engineering disciplines, of Arabic, of visual communications in the design group, architecture, all of the programs and all the bits and pieces that I know we have on campus that exist in small pods, and finding some way to really blow them out, especially around this thinking of product design. I'm really proud of the team, what they've accomplished. They've got a really neat product, and I think what makes it really neat is it hits on two very big themes in design today. And one is that the product and the design adjust to the user. So the team put a lot of thought and a lot of effort into the idea of user-centered design. There is a process, there is a methodology for that, but essentially it's about seeing the user experience the aspects of their design in real time and adjusting to it before building a big prototype. And so I think the team has been very successful in thinking about or achieving this one trend around adjusting to the user. The second area I think that they really hit on is a trend around destigmatizing challenges. And in this case, we're talking about simply the idea of being able to reach 12 inches more. And certainly the team has come up with a physical product that helps address that. But in the process, they're also addressing an issue around sort of mindset, culture, and the fact that the outside world, or outside of those in a wheelchair, now can be sort of destigmatized from the idea of being stuck in that, being in that chair. And so it's not only addressing the physical aspect, but they're also addressing sort of a mindset issue, and that too is a really important trend in design thinking today. So I think they've hit on a couple really big trends, and I want to really congratulate them on the effort that they've put into this semester, and also blazing the trail for us for CCEW, and hopefully the first step in something bigger for the university. So let me turn it to Dylan to introduce the team and let them do their presentation.
So I'm Dylan Carroll. I'm the CCEW Fellow as well as the team leader for the Spring 2014 and inaugural Agile Product Design team. And it really is a pleasure to introduce the team, because I can't imagine a better team to have worked with, a better team to have been the trailblazers for the APD program. You guys can judge for yourselves after this presentation is over, but I think you'll really be impressed by what they were able to accomplish over the course of the semester. And yeah, I think you couldn't really ask better of the first team to go through a program like APD, and all that with having had two weeks less than a typical CCEW team to work on their product due to a slight delay at the beginning of the semester. But I knew we had a winning team when just 2 weeks after they started working on it, they already had a working functional prototype of the wheelchair lift idea. Now, it was pretty rough. It was basically a 15 or 20 pound spring about that big around, about that tall, and it was sandwiched between two slabs of wood. And you compressed or released the slabs of wood by turning a crank and cable mechanism like what you would use to pull a car out of a ditch. So it was pretty rough. It weighed a lot, but it taught the team two very important things. Number one, it communicated the idea and the vision of what the product would do, so it was effective in that regard. But it also, it told us that a 15-pound spring wasn't the way to go with our design. So in that case, we were living up to the agile part of agile product design. And we also had probably the most interesting staff updates every other week. So in fact, in our first staff update, that same prototype exploded pretty spectacularly. The team was disassembling it to sort of take it apart and take the weight off the top after we had finished demoing it. And all of a sudden we hear a big crack, and a piece of wood goes flying off the side. And it was only barely held on by the metal cable that was bolted into place. So after that, we joked that we were going to bring safety glasses to each of the presentations, or each of the demos after that. I'm also incredibly proud of the team because they were able to compete and do quite well in the Sooner Launchpad New Venture Pitch Competition. And that, I think, is a lot for a team that is comprised of, where four out of the five of them are engineers, and not one of them is a Price business major. So the fact that they were able to compete and do quite well in that, I think, says a lot about how versatile and how talented the team as a whole is. So we didn't just work hard, we also had a lot of fun together. It really was a pleasure to get to know each and every one of them, from potluck dinners to playing paintball. And yes, we won all of our paintball matches. It's definitely been a fantastic semester. So I would now like to introduce Team Levaté, Daniel, Andrew, Ethan, Michael, and Lauren.
I'd like all of you to meet Dwayne. Dwayne Farley is an entrepreneur and the CEO of his own tech company in Dallas. Now, what you can't tell from this picture is that Dwayne is also a permanent wheelchair user. And as a result, he faces reach-related challenges every single day of his life. Now, Dwayne has remodeled his home and his office to suit his physical needs, but he still encounters environments unadapted to his reach on a daily basis. Let's say he goes to the grocery store and he wants to buy his kids a box of cereal. If that box is on a shelf that he can't reach, what he's told us that he'll do is he'll grab something he can reach, throw it at the box, knock it down, and then pick it up. Now, obviously, Dwayne hasn't let physical challenges get in the way of his living life. But these same challenges discourage thousands of other wheelchair users to the point that they leave the workforce in the United States every single year as a result. Now, we've heard stories like Dwayne's from over 50 other wheelchair users, and while we've been continually impressed with their ingenuity in environments unadapted to their reach, we think they could do better. And that's why this semester, our team has invented Levaté. Levaté is an affordable accessory that attaches to the bottom of wheelchair users' ultralight chairs and lifts them and the entire chair 12 inches from the ground. We've developed a plan to sell Levaté nationwide and anticipate, after incorporating as a limited liabilities company and operating for 5 years, to earn nearly $10 million in profit and sell 19,000 units, which translates into 19,000 lives for which Levaté restores reach, dignity, and independence. Hi, I'm Daniel Mester, an Arabic and Economics junior from Hockessin, Delaware.
I'm Andrew Stewart, an industrial engineering senior from Edmond, Oklahoma.
I'm Ethan Van Mater, a mechanical engineering senior from Edmond, Oklahoma.
I'm Lauren Gilbert, a chemical engineering major from Austin, Texas.
I'm Michael Petrie, a mechanical engineering senior from Richardson, Texas.
Our team leader is Dylan Carroll, and our industry mentor is Helena Hipp. Wheelchair users face significant reach-related and physical challenges in unadapted environments daily. And while some users like Dwayne use ingenuity to conform to these unadapted environments, they still discourage a lot of wheelchair users to the point that they leave the U.S. workforce. And we've calculated that were it not for these physical disabilities that wheelchair users encounter, there could be 317,000 additional people in the U.S. workforce. Additionally, I mentioned that wheelchair users like Dwayne can retrofit their home and their office to suit their physical needs, but those retrofits are expensive. One home or office to be remodeled can cost between $5,000 to $10,000. Finally, we've heard from wheelchair users stories about how they teeter precariously on the edges of their chairs to reach that book or mug in a kitchen shelf. And it's this kind of unsafe interaction in an environment that's unadapted to their reach that causes over 100,000 wheelchair users to go to the emergency room with fall-related injuries every single year in the U.S. So now that we understand a little better the problems that wheelchair users face in unadapted environments, I'm going to turn it over to Andrew, who will tell us the solution that we've developed in Levaté.
Thank you, Daniel. Levaté is an affordable aftermarket pneumatic lift that raises users 12 inches to more easily interact in their everyday environment. It empowers users to reach that extra shelf in the grocery store, to more easily access that gas, the card swipe mechanism at the gas station, to potentially even potentially even re-enter the workforce. More specifically, Levaté aims to increase the independence of wheelchair users by extending their reach 12 inches, being a manual operated device, and also have independent detachability. When we first started to design Levaté, we interviewed wheelchair users and asked them, what are the main design characteristics that we need to incorporate into our design? And overwhelmingly, they had two main aspects they wanted us to look at. One, a manually operated device, and two, having an object that would be really easy to attach and detach from their wheelchair by themselves. Now we asked them, we probed further, why don't you use electronic devices that are currently on the market? And they had two parameters why they did not. One, they were very, very expensive. And two, it didn't give them the sense of control over their everyday environment. They had to depend on the electronic device to interact in the environment around them. So taking those two considerations into account, we designed Levaté to be a manual lift that users can power through the use of their wheels on their wheelchair, which gives them that sense of control and normalcy in their everyday life. Additionally, by making Levaté independently detachable, users will be able to add and remove the device at will without the aid of a family friend or a caretaker to aid them in this process, which is very crucial when considering that wheelchair users, when they get in and out of their car, disassemble their entire wheelchair and put that in the seat next to them out whenever they get in. So having the option to add and remove Levaté, a very lightweight product, gives them that sense of independence. Second, Levaté will be an affordable product. We interviewed 10 wheelchair users with over 40 survey responses. We asked them, how much would you be willing to pay for a device that accomplishes Levaté's goal? And overwhelmingly, they said quite a bit. So we took the average of all the responses and came up with our $1,000 price point. And again, with keeping the customer in mind, we're trying to keep our price point as low as possible to reach a higher number of users. And lastly, safe. Levaté is a safe solution to the unsafe situations users put themselves in on a daily basis. Additionally, by having a mechanism that lifts from underneath the seat and has an expanding base that goes out as it is being operated, it allows that sense of safety while you're using the product. Users want to be able to have that sense of normalcy whenever they're raising up and have the same situation where they're on the ground sitting in their wheelchair whenever they're in the raised position. So in order to incorporate this into our design, we had to consider these aspects. Next, we took an iterative design process and human-centered approach this semester for our prototyping that we accomplished. We had several different iterations of our prototypes, and each one we tried to isolate a simple mechanism that we would like to incorporate into our final design. Like Dylan mentioned earlier, our first design incorporated a compression spring that was crank operated, and while it served as a proof of concept for what we were trying to get across, it did not really show the attachment mechanism or the other aspects of the function that we were trying to accomplish. And additionally, with busting at the bi-weekly, we had to come up with a new idea. So our second idea, we moved on to a scissor lift technology, much like an everyday car gym. And the good aspects about this design was the fact that the user could use it and raise themselves incrementally or modularly and not have to raise the entire 12 inches. And while this was also a really good design, there were some flaws that came up as we were actually making it. And the fact that the parts that were required to build the prototype weighed more than we initially wanted to, or it weighed more than the parameters of 10 pounds that we had set for ourselves. So next, we looked at a telescoping pneumatic lift. And the way that this would work is that the telescopes would raise as air pressure is introduced into the system and creates a pressurized system, and would raise the entire telescope to the desired amount. And while we were making this prototype, we were very encouraged by the fact that we could prove our concept using an air compressor that we found in the lab that we were working in. However, being students, there were limitations to our prototyping abilities. We couldn't create a perfect enough seal to create an airtight system. And so, because of this, we have a new design that we came up with right here. This involves the use of a pneumatic cylinder to power the device. We initially pump the device using a bicycle pump to lower it, and it will raise the wheelchair. And then as soon as I start releasing air in the release valve, it will lower. So now that we've proved that our functionality is there and that we can actually make prototypes prove what we're trying to accomplish, moving forward, we'll be incorporating the wheel power design into our next prototype and taking into account aesthetic considerations to make Levaté a viable product. So now that we've talked about how Levaté solves the problem, Ethan's going to discuss how we got our design and how we're going to protect it.
So the human-centered design approach that we use for Levaté is one of the most unique things about this whole process. It's this design approach that made Levaté something that's truly unique, something that is truly better than other wheelchair lift devices that exist, because we have taken the customer and actually figured out what processes or what certain aspects of a device they want most out of it. So by doing this human-centered design approach, we used a new process called experiential prototyping. This is a simple process that basically, instead of building a full prototype, you prototype certain aspects of your device with something simple and fast to test whether this is something the user would want. For example, we tested the weight of our device. We had weights put on the bottom of the wheelchair and had wheelchair users wheel around and ask them, how does this feel? Does this feel better? Does this feel worse? And we did this in iterations from 5 to 25 pounds to see what our weight limit should be. Additionally, we had wheelchair users lift up weights in a bag to see what weight they would want to consistently lift in and out and attach and detach from their wheelchair. And this is how we came up with our weight threshold of 10 pounds. So we use this similar process for all the different aspects of Levaté, including lift height, point of contact, weight, and attachment style. It's these aspects of Levaté that have led us to search out the patentability of Levaté, to search out these unique parts of our wheelchair lift device that may actually be patentable in comparison to other devices. So we've been working with the Office of Technology and Development in Norman to see what aspects of Levaté are patentable. We found that our new wheel-powered mechanism is something that doesn't exist on any wheelchair lift device on the market today. It's something that tailors to the user very simply. It's a simple movement that they do on a day-to-day basis, and it's something that wholly includes the human-centered design aspect. This is something that they will want to use. We're also filling out trademark forms to protect aspects of Levaté that may not be patentable, that may exist in other wheelchair lift devices on the market. And finally, the independent attachability of Levaté, which may be the most important aspect of Levaté that we found through the human-centered design approach, is something that we found no other wheelchair lift device on the market today includes. There's no wheelchair lift that doesn't include the aid of someone else, or something that they can easily attach and detach to get in and out of cars and in and out of environments on a day-to-day basis. So let's take these aspects of Levaté and look at how they compare on other wheelchair lift devices on the market today. Levaté is the most cost-effective, efficient solution for wheelchair lift devices on the market. We've compared 3 other devices, those including the Levo standing chair, which is a device that lifts the user manually to standing height, the Heartway Power electric chair, which is an electric wheelchair that they can wheel around on and has an electric lift that's incorporated into the device, and then finally the Retro Lift, which is most like Levaté, as it's an aftermarket add-on that lifts them from their seat. So based on these customer surveys, we've come up with 4 different metrics to compare each of these devices, those being cost, extended reach, ease of use, and weight. In comparison, each of these devices costs a ton more than Levaté. Levaté's price point of $1,000 remains well below even the closest device, the Retro Lift, at $6,000. Each of these devices, especially the power electric wheelchairs, are something that are very difficult for wheelchair users to afford, costing up to $50,000. Secondly, the extended reach of each of these, although they may extend the user to a new height, for example, the Retro Lift at 17 inches extends the user to an unsafe height from what we've found through our human-centered design approach. This height is something, because it lifts them from the base of their chair, that makes the user feel unsafe, and something that they will not want to invest in. And finally, the ease of use of each of these, we've said is low because the Levo standing chair, for example, requires certain physical abilities to even operate. It's something that, although it lifts them to standing height, only certain wheelchair users can use this device. The electric wheelchair is something that is easy to wheel around, but it's, like Andrew said, something that wheelchair users have to depend on. And the Retro Lift, as I described above, makes users feel unsafe because it lifts them from the base of their chair. And then finally, the weight of each of these devices is way bigger compared to Levaté at our weight threshold of 10 pounds. Even the Retro Lift, which weighs only 35, is still much larger than anything that wheelchair users want to take in and out of environments on a day-to-day basis. And electric wheelchairs, although they seem convenient, they can weigh up to 300 pounds. This is something that is difficult, requires retrofitted vans, and something that is not convenient for manual wheelchair users to use. So now that I've described and compared the different aspects of Levaté, I'm going to give it over to Lauren, who's going to tell you guys about what wheelchair users we're going to be looking at getting Levaté to.
Levaté will be targeting the 125,000 wheelchair users who are employed or seeking employment. Let me tell you how I got to this number. There are 1.5 million manual wheelchair users in the United States today. Of these, 614,000 are in the working age of 18 to 64. We've chosen to target the 125,000 of these who are employed or seeking employment because we anticipate that they will have very active lifestyles that lead them in and out of unadapted environments frequently. With a price point of $1,000, this leads to a market valuation of $125 million if we can reach this market in an effective way. We'd also like to expand the market to include other wheelchair users who can make good use of Levaté. For example, the baby boomer generation is actually the largest growing population of manual wheelchair users in the United States. And as these wheelchair users are leaving employment and entering retirement, they can use a product like Levaté to avoid the expensive retrofits that Daniel talked about earlier. Further, we'll be looking to market Levaté to active unemployed wheelchair users. These are people who include stay-at-home moms and students who, although they fall outside of the employed or seeking employment statistics, still have very active lifestyles and are in and out of places like schools and libraries that may be unadapted to their needs. We will be reaching these users by marketing to their wheelchair dealers, and we will be reaching 1,800 of these dealers in our 5 years of operation. This is because we project through industry standards that there are about 15 wheelchair dealers per million people in an urban center. In order to reach 1,800 of these dealers, we have to get to 42 cities in 5 years, and we'll be accomplishing this through a fleet of 8 marketing employees that we'll be accumulating over these 5 years. We'll be employing a radiating marketing strategy that starts from Oklahoma and extends all the way out to the entire United States over 5 years in the phases that you just saw. So now let me tell you about why dealers are so important to Levaté's marketing strategy. Add-on makers like Levaté go through dealers like Allen Holt and Mobility Living, incorporated in Oklahoma City, to aggregate the sale of wheelchairs and accessories to their users. They fit custom wheelchairs and place these orders and make sure that they have access to the accessories that make their lives more livable on a day-to-day basis. Some of these accessories include the new drive mobility push drive propulsion system and the Rio Mobility Dragonfly hand cycle. We've chosen these as points of comparison because they are also manual wheelchair accessories, and they have similar price points to the price that we project for Levaté. So at $1,000 that the customer pays, dealers will take a 25% commission from that price, and after paying $115 for contract manufacturer, Levaté can expect over $600 in profit for every unit that we're able to sell. And we've already started forming the important relationships to make this happen. We've already spoken and started building important working relationships with 10 dealers in Oklahoma, and we'll be reaching out through their professional networks to reach the 1,800 dealers that I mentioned earlier. Further, we're also reaching out to our customer base directly. We've started to talk to the CEO of the Endeavor Games, and we will be setting up a booth this summer, and we're very lucky that this largest sporting event for people with disabilities in the United States is held right in our backyard at the University of Central Oklahoma in Edmond. We're also in touch with national sports teams like the Chargers in Oklahoma City. They're part of the National Wheelchair Basketball Association, and by reaching out to this organization, we'll be able to get in contact with the epitome of an active wheelchair user, and we can get feedback on our designs and have really great prototyping sessions. So now that you've seen how we're going to be entering the market, Michael's going to tell you about what this means for our financial future.
Thanks, Lauren. So at that $1,000 price point that we've talked about so much, we expect Levaté to be able to profit in year 1 and get over $9.7 million in profit over 5 years. That's from a total revenue over 5 years of about $18 million, and that's selling 19,000 units in the process. We expect that at the end of 5 years to have a market penetration of about 15%. Now, we think this is a very realistic estimate based upon our conversations with wheelchair dealers, wheelchair accessory manufacturers, as well as the 40-plus survey responses that we got from wheelchair users themselves. All of this is with startup costs of only about $250,000, which cover all of the costs in year one except employment. Now, speaking on costs, we have costs that basically fall into three main categories: manufacturing, employees, and marketing. As Lauren briefly mentioned earlier, our manufacturing costs are only about $115 per unit now. Back when we had the scissor lift idea, our scissor lift prototype was considerably more. But with the bang for the buck that we're getting with these telescoping pneumatic cylinders, we think this is a very low estimate, or a very much more appealing estimate. We plan to have 2 employees starting off, a CEO and a CTO, as well as 2 full-time salespeople, all paid $50,000 apiece yearly. We plan to expand those 2 full-time salespeople in year 1 up to 8 salespeople by year 5. Now, this marketing category here, this $93,000 in year 5, is not the salaries for those salespeople. It's everything in addition to their salaries. So that involves travel and lodging to and from conferences and to and from speaking with dealers directly face-to-face to get Levaté into their hands and saying, this is what it actually is, and this is why I think you should sell it. Looking forward, we envision the next steps for Levaté falling into 3 main time periods, which are essentially 3 main categories. This upcoming summer, we are participating in the Sooner Launchpad Accelerator, and during that time, we will be finishing our prototype as well as applying for a patent for the wheel-powered alternative. We feel like it's a very natural movement that has not been tapped on any competition on the market today. So we think it's incredibly innovative. As well, we will be finalizing our business plan this summer towards the end of that accelerator, such that in the fall, we can begin our manufacturing phase. And that will involve beginning a 3-month clinical study, which isn't quite as scary as it sounds. It's essentially taking the prototypes that we have of Levaté and putting it in the hands of 3 to 5 manual wheelchair users for 3 months. During those 3 months, and at the end of the 3 months, we get their feedback and we start to make changes to the design. Once we feel like we've come up with a really good design, particularly incorporating those bits of feedback that we have, we'll be beginning the process of contacting the contract manufacturer to get Levaté started. Then in the spring, we will focus more so on commercialization. That will involve approaching the dealers that we've already talked to, those 10 dealers that Lauren has mentioned, and again, taking at this point, a manufactured product and putting it in their hands and saying, you remember that idea that we talked about 6 months ago, a year ago? This is what it actually turned into. This is how it works. This is how much it costs. This is how much you can expect to earn per unit that you sell. And then hopefully by the end of spring 2015, we'll be launching Levaté on the market. This semester, we have been very proud and very excited about the idea of Levaté. We feel that the human-centered design approach that we've taken has resulted in something that is incredibly unique and is unlike anything on the market today. We plan that in our 5 years to earn over $9.7 million in profit, but more importantly, impact 19,000 lives in the process. And we don't anticipate this being a small change. We anticipate this being a massive increase in users' independence, reach, and capability. We'd like to thank you today for coming to our presentation, and we'd like to open up the floor for any questions and comments.
How long is Levaté supposed to last? Like, will it last for the entire lifetime of the wheelchair user, or 5 years, 10 years, the actual device?
We expect that the actual seals are probably going to be the part that's, I would say, the most flimsy or need the most maintenance. Those are fairly small components. They don't cost that much. Overall, the structure of Levaté should be fairly sturdy. I don't think that's going to be any problem. I think that should last the lifetime of the chair, which in most cases is only about 4 or 5 years. A lot of manual wheelchair users replace their ultralight chairs at $3,000 to $4,000 a piece every 3 or 4 years. So it should last definitely that amount of time.
Where are you getting the funding for the patent application process?
You can get a nice book called Patent It Yourself. Do it yourself about $100.
What are the adoption rates for your competitors in the market?
So we've talked to a couple of accessory manufacturers, and we've seen that they also get a capture
see it work.
You want to see that again?
Put somebody in it, let's see.
Excellent point. Sorry.
A quick question on the design. Is there going to be weight instead because of what we place on it, or is it going to be for anything that's what any size is?
So in response to your comment about and it kind of goes with both of these questions, this cylinder is actually not rated to hold enough weight for someone to sit in the chair and it has to be lifted. However, the telescopes that we've designed should be able to hold the pressure that we've calculated needs to be in it. And so that design will have to be a custom-made thing that we don't have access to right now for prototyping, but that we can be building and prototyping in the future.
Do you guys have any plans for a system to replace that hand pump to make the air compression a little bit easier for the user?
So, great question. Michael mentioned that when we were going to be going through the Sooner Launchpad Accelerator, that we'd be exploring a wheel-powered alternative design. So what we want the end game design for Levaté to be is there is a mechanism that pumps the pneumatic lift directly through a geared attachment to the wheels of the wheelchair. So since this is, as Michael said, the most natural motion for wheelchair users in their day-to-day lives, that's going to be the design that we shoot for, although we still have to hammer out how to exactly connect the pump to the wheels. We're working on that.
You mentioned that you were going to break even during year one, and you talked about how the cost of employment and those few other things. The cost of research and development, prototyping all this out, did that fall into that place also, or where are you going to find the cost for that?
So we've calculated that as part of the startup costs, in addition to manufacturing the tool up and the necessary legal funds that will be necessary to actually start filing the patent. We didn't know about Dr. Schmidt's $100 patent thing, but we've definitely calculated that within the startup cost of $250,000.
Will you guys be filing the patent, or will the Office of Technology Development be filing? Or do you know?
So the IP as it stands belongs to the University of Oklahoma. So what we'll have to do is license the IP from the University of Oklahoma, which will enable them to get royalties from any profits they make. And then the patent will be filed by us on their IP. So it'll be a technology transfer kind of situation.
The $250,000, does that include the amount it's going to take to get a production run of these going, say, at 10,000 units? Like the upfront cost that you would have to pay the manufacturer in China to build 10,000 or more.
So part of the $250,000 is all the costs necessary to cover the materials and the burden labor rate for startup, as well as all the tool costs. So any molds that the manufacturer has to cast are included in the startup costs. And we won't be making 10,000 units in year one. We anticipate with a smaller market penetration that we'll only need to make 1,250 to achieve those revenue and profit figures that you saw earlier. So that'll be how many units we'll be paying for.
If you could go back and do the process again, what would you do differently?
I think the major design flaw that we had for our semester as a whole was we didn't consider what Levaté can actually look like just purely from a conceptual standpoint. We took a more of an engineering approach, which, as you can imagine, core engineers would do. We didn't really consider the final product. We took the iterative design process and went, okay, we had this aspect, how do we work this? We have this aspect, how do we make this work? We didn't see the whole picture, which if I go back and review that again, I think we would start with, okay, what does the product accomplish? What's the big picture? And then take smaller steps from there instead of the smaller to the large approach.
Do you think you need insurance to protect against any defective products or accidents the users might have?
So as it currently stands, Levaté is going to be classified by the FDA as a Schedule 1 device, which means that it's not a medical device, and as a result is not going to be insurable by Medicare, Medicaid, the VA, or any other major insurance company. So Levaté isn't going to be insurable. That's part of the reason we have the lower $1,000 price point that we have. As for the liability component of your question, because Levaté is a Class 1 device, there isn't a whole legal procedure that you have to go through to register the device before you sell it. However, we are anticipating getting Levaté certified by the Rehabilitative Engineering Society of North America, because their stamp of approval means that they think the device is safe. So we're definitely going to be working towards that. And in the event that there is a liability suit brought against Levaté, we've incorporated the necessary costs into our financial model as well.
On y'all's design, y'all have an idea of futuristic changes within our wheelchair design. As you see from the green model, that's like an early 90s, 90s model wheelchair versus the newer models that are there on the table and it's so have y'all taken into consideration for future changes in our design of wheelchairs?
Right, so that mainly hits at the attachment style that we're looking to have for the Levaté fit onto a chair. And as you well know, and maybe other people might not be so familiar with, the style of the wheelchair does change a lot, and the ultralight wheelchairs have a lot fewer places to attach a mechanism on the bottom of the chair. And so we incorporate using a clasp style mechanism that can be made to fit onto the ovular shaped bars that are more common in ultralight wheelchairs that have been coming up since the recent past. And so we think that those will need to be adjusted as by the dealer when you first get it. And so it will be fitted to one particular chair. And then as the chair changes, it can be fit to a new chair, depending on where the points of access are.
If we don't have any more questions, let's give the team a hand of applause. The CCEW staff is really pleased and really proud of the APD team and Team Levaté in their presentation and what they've done over the course of the semester. Before we end the night and allow you all to enjoy some refreshments, I do want to call on a few people who will be returning or coming into the APD fold for next semester. So, as team leader next semester, Michael Petrie will be returning. In addition, Andrew Stewart will be returning as the senior engineer. We also have Jonathan Schick, a entrepreneurship and visual communications double major, who will be a new APD team member. And Patrick Stevens, a chemical engineering junior, who will also be a new APD team member next semester. And there was also Renu Nagoran, who will be joining the team next semester. He wasn't able to make it tonight, but he is the 5th team member. So, thank you all for coming out tonight. I hope you enjoyed the presentation. I hope you enjoyed seeing the product that this team has worked so hard on over the course of the past semester. I encourage you all to come up, check out the prototypes after we get finished up here, talk to the team, figure out, get a sense for where Levaté is going and how the team is going to stay involved with it. So, thank you all very much.